Hello, welcome to IB Chemistry. I am Mr. Laughlin. There's a picture of me here. I am super happy to be teaching you today about chem. I'm so sorry I'm not there in Italy yet. I hope I'm going to be there very soon. But until then, we get to do this over video. But it's going to be great. A few things about myself. I have a beautiful family, a wife and a kiddo. He is 4 and he loves dinosaurs. I love chemistry and rock climbing and music, and I love to play guitar. And I'm excited to get to know you. I know that you're my only student right now in IB Chemistry, so it's going to be fun to kind of go through and learn all this stuff together. Um, Today, we're going to start at the very beginning of the syllabus, structure 1.1. And before we jump totally in, I just want to talk about chemistry in general, and what the study of chemistry is. Basically, we're looking at what is the universe made of, right? And there are so many different questions we can ask that are interesting and exciting. Like, why do things smell the way they do? Why do things have certain colors? Or can we make new colors? Why are certain materials resistant to heat? Why can you heat up steel to really high temperatures before it bends or breaks? How do we change one thing into another thing? All right. There were people that were obsessed with changing things into gold hundreds of years ago. So, is that possible? Is that not possible? How can we make new things? Like, how do we make nail polish or nail polish remover? Or how can we extract gold from the earth? These are all chemistry questions, and a lot of these we will answer, or at least hint at, um, in our time together over these next couple of years. But today we're going to start with the very beginning, um, and that is how can we model the particulate nature of matter? And my understanding is that you have had some chemistry in the past. So today I'm just going to trust that. I'm not going to hit like every little thing, as we've got lots of things to cover through this course. Uh, but with that in mind, please, especially because I'm not there, email me questions, or if I'm talking about something that you have no idea about and I've skipped over something, please let me know so we can be on the same page together. Um, so let's look at this question really quick. What kinds of things could be classified as a particle in chemistry? So I would like you to think about that. Come up with some in your head. Perhaps pause the video for a moment. I'm going to take a drink of water, give you a chance to think about it, and then I will tell you some answers that I came up with. So, particle. There are lots of possible answers you could have come up with. There are subatomic particles, like protons, neutrons, electrons. There are atomic particles, right? The atoms, the elements themselves, like gold, iron, platinum, carbon. There are molecules and ions. There are colloidal particles, so particles suspended in something else. Like you might find something suspended in milk, or like fog particles suspended in the air. Or there's even aggregates and clusters, so like soot made from carbon, like you burn something and you have that soot that's kind of hanging uh, and clumped together. Those are all good options, and things that could be classified as particles. So, yeah, here, part A, elements, compounds, and mixtures. This is what we're going to talk about today. We're going to try and identify what each of these is and how they differ from each other. So, I'm going to ask you some questions. I just want you to do your best, and obviously, and hopefully, you found a space to be with in another class or something watching this video. I hope that's the case. I've been talking to some of the other teachers there to try and make sure that's happening. Hopefully that happened. But some of these next slides, I'm going to ask you to classify some things and just do your best. I'll give you a little bit of time, and then we'll talk about um, how they are actually classified and what that means. So for this, I would like you to classify each of these substances, so A, B, C, D, E, and F, as monatomic, molecular, or a lattice structure. So maybe in your notebook, just write out the letters and then write one of these words next to each of these letters. And just do your best on this. Maybe you know what those words mean, maybe you don't, but take a guess if you don't. And perhaps pause the video right now, do that real quick, and then we'll talk about the answers. So let's go through the answers and kind of talk about what they mean. So A, we can see these are particles, right? These two particles that are clumped together, and then there's some space, and then two more particles, space, two more particles, right? So this one is molecular, and that is because we have more than one atom, right? Each of these represents an atom. So these two atoms are clumped together. They're not monatomic, which would mean one atom. They are more than one, and they are seemingly bonded together. So we're going to call that a molecule or a molecular substance. B would also be molecular, right? It's three of these atoms or particles bonded together, stuck together. It's not just one, right? That's monatomic. This is molecular. C is lattice, right? So these are stuck together. There's a bunch of them. They have a pattern. They're repeating, right? There's a bunch. This is what a lattice is. A lattice is like a repeating structure of atoms. So monatomic is one atom, so D would be monatomic. Molecular is multiple atoms bonded together, right? And then lattice is multiple atoms bonded together that have a repeating structure. So this might be like an ionic compound, or even like a crystal has a repeating structure. They have lattice structures like that. So then E. E would be, this one's interesting. This is a lattice, right? It is repeating. You don't have to have different things in there. It can be all the same thing, like diamond is a really beautiful lattice structure. So maybe this one is diamond. It has a nice repeating structure of the same thing. And then F, this is molecular, right? Because we have a bunch of things bonded together. And then we have another bunch of these things bonded together next to it. So the key point here is to make sure we know the difference between molecular and lattice, right? Molecular things are bonded together, but the repeating things are not attached to each other, right? So maybe this is water. This is a water molecule. It's floating next to another water molecule. With a lattice, the repeating atoms are all stuck together. The pattern makes a thing, like a solid thing. Like this is diamond, maybe. It has a bunch of atoms all bonded together. So we can see that here. We have this pattern of elements all bonded together, but these two different things are not stuck together. So this is why this is molecular and not a lattice. So here is another question for you. I want you... well, first let's talk about the pictures, I guess. So the different colored particles represent atoms of different elements, right? So each color and size is a different atom. The particles that are touching are chemically bonded together. So kind of like in our last problem, right? Anything that's touching, we can say is chemically bonded to the next thing. I would like you to classify the contents of each box using one of the terms above. So you probably know some of these words. You may or may not know exactly what they mean, but I want you to pick one of these words and match it to a box. Just do your best. Same as before. So maybe take a moment, pause the video, try and match these words. You can write it down in your notebook, and then we will talk about um, the answers. Okay, let's talk about it. So let's go through it from the top. Over here we have A, and we can see we have two different colored particles, and they are bonded together, right? Um, and it looks like that's all we have. We just have four different sets of those two bonded particles. So the correct answer for this is a pure compound. Is a compound because it's combining things, right? Instead of just one element, right? There is multiple different elements, and they are bonded together. So that's what makes it a compound. On B, we have these little blue particles and then this other set of particles that are bonded to each other. So this one, this is a compound right here, but this is not, right? So it can't be either of these. So in this case, this is an interesting one. This is a mixture of two elements. It might be a little confusing because we also have this option, but because these are the same color, we actually call this the elemental form of whatever this is. So maybe this is like hydrogen. This is how you would find hydrogen in nature. It'd be two hydrogens bonded together. So because we have this element and then this element bonded to itself, we call this a mixture of elements. If we want to see a mixture of elements and compounds, we can go to C, right? This is elemental particles. There's just a single thing, right? And then this is a compound that is made of two different things. So this would be a mixture of elements and compounds for C. For D, this is similar to A, right? There are these compounds of these three different things bonded together. That's all we have. So we can say that this would be a pure compound. For E, we have two of the same particles bonded together. And so this is a pure element. And we actually would call these molecules. So maybe this is oxygen, right? If you breathe this, O2, it's two oxygens bonded together. It's an oxygen molecule. But because it's two of the same element, we call it elemental. F, again, would be pure element. It's just the one particles by themselves. G would be a mixture of two compounds. We have this compound with the two bigger particles and the smaller, and then this compound, right? So two different compounds. This would be a pure element, right? All of the same element bonded to itself. This kind of looks like a lattice structure. And then this would be a pure compound. And this kind of looks like a water molecule to me, right? So we're going to learn how to define all these words, but I want you to begin thinking about how we can classify things using them, right? Just looking at particles.